Hi there, welcome back. So now that we have defined what a function is, and we have some idea of what it looks like and what examples are, like we have done in so many previous cases, we want to talk about operations on functions. And there are 5 operations we'll look at. The basic ones, the 4 basic ones, add, subtract, multiply, divide. And the 5th one is known as composition, and that'll be the most interesting one, and we'll get to that in a minute. But let's begin by talking about 2 functions, and we'll then look at operations on them. Okay, so here are 2 functions, and we're going to go through the basics of adding, subtracting, multiplying, and dividing. Okay, so here we are. We're putting down, we'll worry about division on the next page. But adding, subtracting really is all about like terms. So before you have been asked, how do you add 2x minus 3 and x squared minus 5x plus 1? And you just look for like terms. And we always want to write them, remember, in descending powers. So if we add these two guys together, we're going to get x squared minus 3x minus 2. Pretty simple. If we look at g of x minus f of x, just to write that out, g of x minus f of x, we have to bring that negative sign through. And so when we do that, we're going to get x squared minus 5 minus 2 is minus 7x, and 1 minus a minus 3 gives me plus 4. Right? So adding and subtracting, very, very familiar to you, I hope. F of x times g of x. Okay, so we've done problems like this before also. 2x minus 3 times x squared minus 5x plus 1. And so if we multiply through everything on the right side by 2x, we're going to get 2x cubed minus 10x squared plus 2x. And now we multiply everything here by minus 3. And I'm going to write it underneath what I've just written, lining up like terms. So minus 3 times x squared is minus 3x squared. Minus 3 times minus 5x is plus 15x. And minus 3 times minus 1 is minus 3. And so my final result is going to be 2x cubed minus 13x squared plus 17x minus 3. And so, we have done that before, but there's our multiplication. So now let's look at division, which is always a little bit messier. So suppose we're looking at g of x divided by f of x. So we write that like this: 2x minus 3 into g of x, which is x squared minus 5x plus 1. Now let's remember how we do this. First we divide 2x into x squared. This was probably not the best example, but hey, sometimes that's the way it works. So that's going to be 1/2 x. And then I multiply, and I get x squared minus 3/2 x. Remember this? And then I subtract. So I get minus 5x minus a minus 3/2 x, which is minus 5 plus 3/2. And minus 5 is minus 10 plus 3. And so ultimately what I get is minus 7/2 x. Bring down the 1. Now 2x goes into minus 7/2 minus 7/4. And I multiply, and I get minus 7/2 x plus 21/4. And I subtract, and what do I get? So 1 minus 21/4 is minus 17/4. I can just write that as remainder minus 17/4. So that's a pretty ugly problem, but that's the way that we divide, and that's long division, and you have seen that before. So now let's talk about composition of functions, which is a new idea and which is much more interesting than the previous four. So composition of functions. That is written like this. This is kind of like an open circle. Looks kind of weird, but what it really means is this: f of g of x. Now remember what f was? Let's remember. F of x is 2x minus 3. In other words, whatever comes into the function f gets multiplied by 2 and 3 is subtracted. So that's where this becomes very interesting. What's coming into f now isn't x, but g of x. But it works the same as x. And so really what this means is 2 times g of x minus 3. Now let's remember what g of x is. There we go. G of x is equal to x squared minus 5x plus 1. Got to write it down there. So this, when you multiply by 2, you're going to get 2x squared minus 10x plus 2, and then you have the minus 3. And so f of g of x comes out to be 2x squared minus 10x minus 1. Right? So it's kind of like this. X comes into a machine called g, and out pops g of x. That then, in turn, goes into a machine called f, and out pops f of g of x. And f of g of x is simply 2x squared minus 10x minus 1. Okay? Now, a lot of students will think, well, f of g of x and g of f of x are the same. Let's go through the work and show that they're not the same. Okay, so let's look at what g of f of x is. And I've, again, put down what these functions are so they're right in front of us. Well, what does g do to something? We just talk about the g machine. Whatever comes in gets squared, and then subtracts 5 times that thing, and then you add 1. So what that means then is that g of f of x is going to be f of x squared minus 5 times f of x plus 1. See the pattern? X squared, f of x squared, minus 5x minus 5 f of x, plus 1 plus 1. And now all we have to do is simplify this. So the intermediate step would be 2x minus 3 squared minus 5 times 2x minus 3, just putting in what f of x is, plus 1. And now I just have to simplify all this. So I get 4x squared minus 12x plus 9. That's what I get when I square that. And then when I go through and multiply by minus 5, I get minus 10x plus 15 plus 1. So I combine all my like terms. I have a 4x squared minus 22x plus 25. And that is very different than what f of g of x is. So there's no reason why they should be the same. Okay, so that has to do, that's all we're going to talk about now in terms of operations with functions. All right, have fun with your homework.